Big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate. Challenges include analysis, capture, data curation, search, sharing, storage, transfer, visualization, querying and information privacy. The term often refers simply to the use of predictive analytics or certain other advanced methods to extract value from data, and seldom to a particular size of data set. Accuracy in big data may lead to more confident decision-making, and better decisions can result in greater operational efficiency. Cost reduction. Analysis of datasets can find new correlations to spot business trends, prevent diseases, combat crime and so on. Scientists, business executives, practitioners of medicine, advertising and governments alike regularly meet difficulties with large datasets in areas including internet search, finance and business informatics. Scientists encounter limitations in e-science work, including meteorology, genomics, connectomics, complex physics simulations, biology and datasets are growing rapidly in part because they are increasingly gathered by cheap and numerous information sensing mobile devices, aerial, remote sensing, software logs, cameras, microphones, radio frequency identification, RFID, readers and wireless sensor networks. The world's technological per capita capacity to store information has roughly doubled every 40 months since the 1980s. As of 2012, every day 2.5 exabytes, 2.5 times 1018, of data are created. One question for large enterprises is determining who should own big data initiatives that affect the entire term big data is relatively new. The act of gathering and storing large amounts of information for eventual analysis is ages old. The concept gained momentum in the early 2000s when industry analyst Doug Laney articulated the now mainstream definition of big data as the 3 versus volume. Organizations collect data from a variety of sources, including business transactions, social media and information from sensor or machine-to-machine data. In the past, storing it would have been a problem, but new technologies, such as Hadoop, have eased the burden. Velocity. Data streams in at an unprecedented speed and must be dealt with in a timely manner. RFID tags, sensors and smart metering are driving the need to deal with torrents of data in near real time. Variety. Data comes in all types of formats, from structured, numeric data in traditional databases to unstructured text documents, email, video, audio, stock ticker data and financial manufacturing. Based on TCS 2013 Global Trend Study, improvements in supply planning and product quality provide the greatest benefit of big data for manufacturing. Big data provides an infrastructure for transparency in manufacturing industry, which is the ability to unravel uncertainties such as inconsistent component performance and availability. Predictive manufacturing as an applicable approach toward near-zero downtime and transparency requires vast amount of data and advanced prediction tools for a systematic process of data into useful information. A conceptual framework of predictive manufacturing begins with data acquisition where different type of sensory data is available to acquire such as acoustics, vibration, pressure, current, voltage and controller data. Vast amount of sensory data in addition to historical data construct the big data in manufacturing. The generated big data acts as the input into predictive tools and preventive strategies such as prognostics and health management. Telecommunications. Telecommunications is the most data-rich of any sector, with real-time data playing an absolutely pivotal role in both your business and operational decision-making. It's no surprise that for our telecommunications clients, data analytics is now moving to the very banking/insurance. FICO card detection system protects accounts worldwide. The volume of business data worldwide, across all companies, doubles every 1.2 years. 3 retails. Walmart handles more than 1 million customer transactions every hour, which are imported into databases estimated to contain more than 2.5 petabytes, 2,560 terabytes, of data, the equivalent of 167 times the information contained in all the books in the U.S. Library of To understand how the media utilizes big data, it is first necessary to provide some context into the mechanism used for media process. It has been suggested by Nakuldri and Joseph Turo that practitioners in media and advertising approach big data as many actionable points of information about millions of individuals. The industry appears to be moving away from the traditional approach of using specific media environments such as newspapers, magazines, or television shows and instead tap into consumers with technologies that reach targeted people at optimal times and optimal locations. The ultimate aim is to serve, or convey, a message or content that is, statistically speaking, in line with a consumer's mindset. For example, publishing environments are increasingly tailoring messages, advertisements, and content, articles, to appeal to consumers that have been exclusively gleaned through various data mining activities. Targeting of consumers, for advertising by marketers. Data capture.